Okay, in this video, we want to solve this optimization problem, all right? So we given that a closed cylindrical tank of this volume V meters cube, all right, is to be constructed from two sides of a gauge metal. Now the metal for the top and the base costs twice as much per square meter as that of the cylindrical portion. Now what is the ratio of the height to the radius of that tank if the cost, okay, the cost of the construction is to be minimized? All right, so let's look at a cylinder a little bit. So we notice that a cylinder looks like this, and in fact, let me just say a right cylinder. All right, okay, so we have this cylinder. Now you notice that the cylinder is said to be a closed one, which means that the top is closed and then the bottom is closed as well. All right, and this right here is the cylindrical portion. So let me just show you separating this. All right, assuming they are to be formed from different metals, let's separate this and see. So the top is circular. That means you're going to have something like this for the top. The bottom as well is circular, right? Okay, great, because this the sides are parallel to each other. Then this right here, you know, if you cut a cylindrical maybe object, okay, you're going to observe that when you take out the top, take out the bottom, if you cut it, you're going to have a rectangle, right? Which means that this rectangle was folded. Okay, when you fold the rectangle this side to that side, you're going to have the cylindrical portion, which is the body. All right, this is the top, this is the top, this is the bottom. Of course, they are the same circle. Okay, so where this right here, of course, is going to be the radius of the circle, denoted as r, and then the height denoted as h. Okay, we are going to use r and h to represent the radius and the height respectively. Okay, so that is it for that. So what do we do about the cost? All right, because what we want to minimize is the cost, not the volume. Okay, so what that means is that we want to find this minimum cost that will give us a rectangle, a cylinder that will contain this amount of maybe liquid, or that will contain this volume, right? Or that will have this volume V meters cube, where the volume is not given, the actual value is not given, we're just given V to denote it. Okay, and as you can see, in fact, no actual value is given in the whole problem. So in fact, it is a little bit challenging, right? But it's okay. So let's see what we can do from here. So let me put this up. Anyway, we have to notice that you know that the formula for finding the volume of a cylinder is pi r square h. All right, so you know that the formula for the volume of a cylinder is pi r squared h. Okay, all right. That is the first thing. And then we want to look at the formula of finding the cost. But we are not given anything for the cost. So let's suppose that the cost is a certain, maybe a certain value, right? So let's say, suppose, so let me use SPS for suppose, right? The cost. Now, take note, what cost? The cost for the metal, for the top and the base, all right, is what? Twice as much as what? Twice as much per square meter as that of the cylindrical portion. So let's say, suppose the cost per square meter, so per square meter of the cylindrical portion is P, right? So let's say, suppose that of the cylindrical portion is P. Okay, what that means is that the cost for the per square meter of the top, the metal used for the top, and then the metal used for the base is going to be 2 times P. All right, so let me tell you what that means. That is, this is the cylindrical portion which we've gotten out here. Okay, let's say if this is 1 square meter, right, the metal used, this is 1 square meter, it costs P. Now if you try to measure that same square meter, right, let me do this to be a square. So if you try to measure that same square meter on the top, right, this is going to be 2P, the cost for this particular metal. So the small piece of metal you use here is going to cost twice as that of the small piece of metal used here. So same thing with this one. This is because this and the bottom and bottom are made of the same metal. All right, so that is what we have. So what that means is that if you can get the area, the entire area of the top, the metal used at the top, the entire area of the metal used at the bottom, all right, then to get the cost is going to be P, 2P, right? Because this one is P, this one is twice. Take note, twice as much as that used for the cylindrical portion is going to be 2P times the area of this, plus 2P times the area of this, plus what? P times the area here. That will give us the total cost for the cylinder. All right. So let us know what is the area of this circle, what is the area of this circle, and then what is the area of this triangle. All right, so the cost is going to, we can model the cost as this. Okay, the cost is going to be, well, I'll tell you that the cost depends on two things. So what do we get? Well, the top, for the formula of finding the area of this, the top part of the top of the cylinder. Of course, the top is just a circle, right? It's circular in shape. So the formula for finding the area of that will just be the formula of finding the area of a circle, which is pi r squared, right? But here we are going to have to multiply it by the cost for the metal, which is going to be 2 times that of the cylindrical portion, right? So we just say it's going to be 2p. All right. Okay, when we're done with that, we are going to add it with, well, the one for the bottom, which is still a circle, pi r squared, okay, times the cost of per square meter of that metal, which is 2p. So what we are saying is, for 1 square meter, we're going to have 2p, but for pi r square meter, we're going to have pi r squared times 2p. That will be for the top. The bottom, the same thing. And then we add it with, well, what is the formula of finding the area of this rectangle? All right. So what the formula of finding the area of a rectangle is going to be length times breadth. All right. So assuming this is the breadth, and then this is the length. All right. Well, comparing this, because this is gotten from the cylinder, the breadth here represents the height. All right. So we have that the breadth represents the height. Well, what does the length represent? Well, the length will represent this circumference of this circle. The reason is, when we fold, let me show you, when we fold this, okay, something like this, when we fold this thing here, okay, if you can fold it, right, the rectangle, you are going to see that the length of this rectangle will become the circle that will be formed, right, when you fold the thing. So to find the length of that circle is the same thing as saying find the circumference of the circle. So this right here is going to be 2 pi r, which is the formula of finding the circumference of the circle. So all in all, to find the area of this rectangle, we are going to have what? We are going to have the length times breadth, which is going to be 2 pi r times h. Okay, so we have 2 pi r times h. Okay, 2 pi r times h. Let me put it down here, because we need to write something else. We're going to have, that is for the area of this, right? But remember that the cost, to find the cost, we need to multiply this by p. That is to say, it's going to be 2 pi r times h times p. That is, per square meter is going to be p, but for 2 pi r h square meter, we're going to have 2 pi r h times p to be the cost. So the entire cost is this, all right? But well, what does this cost depend on? Okay, as I said earlier, well, we need to know our constant and we need to know our variables. R here is a radius, and the radius will vary depending on what will minimize the cost and what will not, and the height as well. So those are the two things that are going to vary. Every other thing is a constant. Pi is just a number. P is the fixed price. Okay, V is just the fixed volume given, right? So the R and the H are the variables here. So let's put it here, RH, all right? But as you can see, that right there depends on two variables. That is our objective function, this cost function, right? Because that's the function we want to minimize. Okay, we try to minimize. That is the cost of the construction, is the cost we want to minimize. So I'm using cost. Maybe I should even use C for the cost, all right? But it's okay like that. So since we want to minimize this, okay, it will be better, okay, if we try to get that to depend on just one variable. But well, that can be done because we have two equations. The first one is the formula, the equation from the volume, and then the second one is this equation from the cost. So what we're going to do is to make one of the variables subject of formula from equation 1, and then substitute the value into equation 2. And it will be better if we make h the subject of formula from equation 1. So you notice that from equation 1, what happens? From equation 1, h is equal to what? H is equals to v over pi r squared, right? So we are going to substitute this value of h from equation 1 into wherever you find h in equation 2, right? So when we do that, we're going to have the cost to depend on just r. So it's going to be, let me put it down here, the cost, okay, will depend on just r. That will be what? Well, we're going to put this down here to be, let me rewrite it properly. That will be 2 pi r squared p, right? Plus, okay, but you notice that this is 2 pi r squared p. This as well is the same thing as that. So we are going to double this, right? Because adding them together is going to be like a double of the the sum, right? Okay, so this is going to be plus. When we take this, we're going to have 2 pi r hp. But well, what is this h? H is given here to be what? We've been given h to be, or we've solved for h to have v over pi r squared. All right. So maybe let's cancel things a little bit. Notice that this pi will cancel out with this pi here. The h will cancel out with one of these. Sorry, the r will cancel out with one of these r. So we're going to have 2pv over r left here. So let me just put that down. 2pv over r. All right. So let's say 2pv over r. Okay. So that's exactly what we're going to have. And this right here is the objective function for the cost. So we will try to minimize that, right? And the value that will help us to minimize that will be r, and that r is going to be called a minimizer. Okay. All right, that's great. So let's see what we have. Well, to minimize this, we have to take the derivative of it. So we take the derivative of the cost. Okay, so we differentiate that. That is a cost depending on r. We are going to differentiate that. So let me use this notation, all right, to denote that is the derivative of the original thing. So when we do that, we're going to have what? Well, let's differentiate this with respect to r. So you notice the r is just a power function here. Every other thing is a constant. Put 2 to the front and then subtract 1 from the original power. We are going to have 8. That's going to be 2 times 4, which is 8. Then we're going to have, let me just show you what I mean. When you put 2 to the front, it's going to be 2 times 4, which was there already. Then we put the pi. Okay, we can put the p here. And then the r, we are going to subtract 1 from the original power. All right. So when you say r, 2 minus 1 is going to be 1. That is the power of r there is just 1. Then 2 times 4 is just going to be 8. So yeah, that is it. But that's just the first part. So we need to differentiate this as well. So we have 2 times that. We notice that the only variable we have there is the r, which is in the denominator. So to differentiate this is r to the power of -1. Okay, which is just the power function as well. We differentiate this. We take this power here, put it to the front, and then we subtract 1 from that. So we're going to have negative r raised to the power of what? Negative 1r raised to the power of what? -2, which we can rewrite it as negative 1 over r squared. All right. So here I'm going to put this away, minus, okay, 2pv divided by r squared. All right. So we're going to multiply this with that. Of course, that's what we have. Okay. So this is the derivative. But here, after taking the derivative, we are going to equate it to 0, which tells us about the stationary point. Oh, sorry. Yeah, it should be stationary. That is, the derivative should be 0. So at that point, we can either have a maximum or we can have a minimum. And we are going to determine that using the second derivative test. So when we differentiate this again, if the derivative gives us something bigger than 0, what that means is that the r there is going to be a minimum point. In other words, the cost for that r is going to be minimum. But if the derivative is less than 0, that means the cost there is going to be maximum for that r, and that r is going to be called a maximizer. So we take the second derivative of that cost. So this is going to be this cost differentiated twice. All right, so I'm going to do 2 of those slashes that I did. The slash I did once, I'm going to do it twice, which denotes second time differentiating it. All right. Okay, so when we differentiate this, we're going to have, of course, the r is just to power 1. When we differentiate it, it's going to have just 1 times the whole of this, which will stay the same, 8 pi p. This is to power 2. So you apply the power rule, which I did earlier. When you do that, you're going to have plus. The 2 here will multiply with this 2. We're going to have 4 pv, okay, divided by r to the third power. So this is the result for the second derivative. So let's see what we have. Well, notice something here. The second derivative gives us just r in one place. The other r has been reduced. The other r has been reduced to 1 to the power 0. Right? So what do we do? Well, observe, is this thing bigger than 0 or is it less than 0? So let's analyze. Right? Now, 8 of course is just a number and it is a positive number. Pi of course is also a number and it is a positive number, approximately 3.142. P is a fixed price, and physically speaking, the price cannot be negative. Okay, so the whole of this is positive. 4 is, of course, is also a number positive. P is the fixed price, which is positive. The volume cannot be negative, so it's positive, and it cannot even be 0, else we will not have a cylinder at all. Divided by r to the third power, r cannot be negative. So that means everything here is positive, which means the sum will be greater than 0. Okay. since the second derivative, which is this, is greater than 0, what that means is that the formula for this cost is the minimum for this r. That is to say, the r that makes this work, of course this is true for all r, so for this r, this is going to be the minimum. All right, okay, so that is it. So that cost is going to be the minimum. But we are not done here, because the question demands us to find the ratio of the height to the radius. Now back to this, I did mean this thing was less than 0. Okay, that means the cost will be maximum for that r. Or I did mean we had, after checking this, after doing this, we were able to solve for more than 1 r, let's say like 2 r's. Okay, we were able to make 2 r the subject of formula. That would have meant something. All right, anyway, maybe let me just show you what I mean. From here, okay, we can make r the subject of formula. So I'm going to clean this part, but don't forget the question is to find the ratio of the height to the radius of the tank if the cost of the construction is to be minimized. So I'm going to clean from here to maybe here, so that we are going to continue. See what we have. So we have all of this. All right, so since this thing is true for all r, that this cost is going to be minimum. Okay, so let's just make r the subject of formula here and see what this particular r will be. So to do that, we're going to multiply through by r squared to clear this denominator. When we do that, we're going to have 8 pi. Okay, we're going to have 8 pi r to the third power to be the same thing as when we multiply through by r. Of course, r cannot be 0. This and this will cancel, which is going to give us 2pv. All right, just by trying to make r the subject of formula here. So what that tells us is that r to the third power will be what? Well, we are going to divide both sides by 8 pi. That means we are going to have 8 pi, right? 8 pi p. Okay, so let me put the p here. It's going to be 8 pi p. The p and the p will cancel. 8 cancels the 2, and then we're going to have v over 4 pi, right? So this is the result for r to the third power, right? Which means r will be the cube root of that. So let's continue over here. Okay, so we want to find the ratio of the height to the radius. So this here gives us h to be what? H is v over pi r square. All right, so to find the ratio, we need to divide this by r. That is h over r. That is the ratio of the height to the radius. So h over r will be what? Will be this over r, which will be v over pi r squared. Okay, divided by r, that will give us pi r cubed. All right. Okay, so that is it. But what is r to the third power equal to? Of course, we've done that already. This is pi times r to the third power here is v over 4 pi. So we're going to put it here, v over 4 pi. All right. That is what we have from here. That is from the derivative. That is to find the minimizer, right? Or you can call it the critical point. That is what we have for r cubed. Here you can take the cube root of both sides to find r. But it's not necessary, since we just want to find the ratio of these two. We don't want to find the r itself. But if you can still do it, it's still going to work. All right. Okay, so let's see what and what will cancel. You notice that v will cancel out with v, pi will cancel out with pi, v will cancel out with v. Then all together we are going to have this to be equal to 4. All right, let me put it here, to be equal to 4, because yeah, that's going to work out when you take the ratio of those fractions. So what that tells us is that the ratio of h and r, that is h over r, is equal to 4. What that means is that the height is going to be 4 times longer than the radius. Okay, in other words, the height is going to be 2 times longer than the width. Okay, that is from here to here, because the radius is going to be 2 times the radius is going to give us the diameter. Anyway, all right, that was really a lot. All right, okay, thanks for watching, and please subscribe to my channel and share this video with your friends. All right, and I'll see you in our next video.